Hello, welcome to Program with Sam, and this is R Lesson 4. Okay, so today we're going to be looking at data visualization in R. Mostly, we're just going to be having a look at some of the graphs that can be made using R, because R is actually a surprisingly powerful tool for when it comes to data visualization and actually making graphs for display. It's very similar to Python in that sense, only in my opinion Python is probably better. But for the sake of the tutorial, we're going to be looking at data visualization in R. So one of the first things you're going to want to know is how can I plot a line graph? Now, in order to do that, you're going to need the plot command, but we're also going to need data to plot. So let's start by just generating a random vector of sorts, and we'll just sort of say C 20, 30, 14, 5, 10, 6, 20, 23, sort of maybe 13. We've got that random vector. If we run that, it's created the vector x. And then what we can do to plot the line graph is we can say plot x, and we can do type is equal to O. And if we run that, it generates ourselves a line plot. And you've got your index here, which is sort of like the position. You could probably set the actual the thing to be something else, like the y-axis to be something else, just by saying y is equal to and then the vector that you want to use for it. But for the purposes of this, an index is fine, and that just generates the bar chart, the line graph, even with the data points there, each linked by a line. Another graph that you can make in R would be a histogram. So for instance, if we were to go hist, which is the histogram function, and just throw x in there, it then generates the histogram of the data that we created. Obviously, it's completely arbitrary, but that's how you'd go about making the histogram of x. Now, each of these graphs that we're showing have a multitude of hyperparameters for stuff like, or parameters rather, that have for stuff like the title, the color schemes, all of that you can find in the R documentation. And it's one of those things that is sort of, if you need it, look it up. But for realistically, in terms of plotting a basic graph, you've just done it in that. Another one that's available in R would be a box plot. Now this is useful for sort of looking at frequency distribution of a variable, or even some other things like comparing the frequency distribution of multiple different variables in a data set. So in order to do that, all you need to do is type in box plot, aptly named, and then give it the data, and boom, that's a box plot of our data. It gives us the middle points, the two quartiles, and then the outliers will be marked as an X outside, but for the purposes of this, we just have those lines marking the upper value and the lower value. Now, in order to do a scatter plot, it's a lot like the line graph. In fact, it uses the same command, only this time we're going to specify no type, which means it's not going to know which lines or what type of lines to draw. So for instance, if we just go plot X, that just plots the data points as they are in the actual data set. So when it comes to plotting a scatter graph, it's a very simple process. It only gets more complicated actually when you want to do a line graph, because then you have to pass a specific argument. In this case, we did O, which essentially keeps the points there. But if we were to just do L, that would just do the line without the points. And that's another example of those parameters that you're going to need to look up and tune to get the graph the way that you want it. A final aside here is that there are a multitude of plotting libraries out there for R. So what's coming with the bog standard just base packages of R may not necessarily be enough for you. And it's in those situations that you'd actually have to go out and use what we've talked about in previous episodes, where you've actually downloaded, installed, imported a library that has the functionality you need. Unfortunately then, if it's a completely custom one, i.e. one that you have to get through GitHub, the documentation may not be as good. Now, in my opinion, the R documentation isn't very good as it is, so the chances are documentation of standalone GitHub plugins or libraries is not going to be much better. So just be mindful of that when it comes to sort of creating your plots in the future. And that's going to cover it for this time. This has been a very, very whistle-stop tour of plotting in R. Giving you the very basics, the ones that you're probably commonly going to use in your statistics and mathematics. If you'd like to see more, I can do another one if you just leave a comment. But realistically, a lot of it is going to be down to you to look up the documentation depending on what you want. at the end of the day, the reason you'd be using software like this or creating your own graphs through R or Python is because you want something that other places cannot offer you, like Excel, for instance. But next time, we're going to be having a look at mathematical functions in R and sort of using R to solve mathematical functions, as well as solving differentials, and we're going to take another look at matrix decomposition. If you'd like to follow me at Program Sam blog or follow the blog directly at programwithsam.code.blog, that would be much appreciated, and I'll see you in the next one.